Hello and welcome back. This is lesson, let's write it up here. Lesson 2.4. Yeah. Examine the diagram. All right, I'm examining. I see some lines. I see some points. I see two triangles. Is triangle ABD congruent to triangle CBD? ABD, CBD. Okay. List all the things you would need to know in order to know for sure that the two triangles are congruent. Okay, so congruency is this concept that if you lined up one shape on top of the other, it looks like you just have to reflect over BD, reflect it over, and then would it line up exactly with the shape beneath it? Looks like it, but although we're getting better and better with computers, like this was printed with a computer that could be exact, we don't trust things that look. We have to know. So what do we need to know? Well, we have another idea of congruency for polygons. Congruent for polygons. Polygons are shapes made of straight lines and angles. So for polygons, we can say two things are congruent if all corresponding sides are the same length. So what do I mean by corresponding sides? Like if this, let's say, so if this is a right angle, we don't know that for sure, but let's say it is, and this is also then a right angle. This side would be the hypotenuse, and this side is the hypotenuse. Those correspond, they match up. Corresponding means match, they match. If all corresponding sides are the same length, okay, that's good, that is half of it, and all corresponding angles are the same measure, then congruent. Then they're congruent. So then that's all the things we need to know. We need to know that BC is the same length as BA. We need to know that angle C is the same as angle A. We need to know that angle ADB is the same as angle CDB. And this we know equals itself. I'll put marks here anyway. Oh, and then we should triple mark this one. There. Oh, and then two arc mark these. All right. Let's write all that down with symbols. Let's start with just this length. So AB. Let's do segment. Segment AB is congruent to segment CB. All right. So segment AB is congruent to segment CB. Segment AD is congruent to segment CD. What's that? AD and CD. Okay, these two. Yep, the triple markers. Those are congruent now. Well, at least if we knew that, it would help us prove that the two triangles are congruent. BD is congruent to itself. That's called the reflexive property. We'll go over that more later. Angle A and angle C got to be the same. That's the only angle at these 2 points, so I'd use the single letter naming. But there's two angles at point D. There's one angle on each side, so I had to use the triple letter naming. Notice how D is the center letter on both angles because that's the angle we're talking about. And same thing here, B is the center letter. So I'm talking about the two angles up here. There's one on each side. I had to triple name it. I started the D for both DBC and DBA, those two angles. Okay, if we knew all those 6 facts, then we would know that the triangles are congruent. Yay. So you might be wondering, why did I say that if they have the same length and their lengths are equal, like they're measured, but then I didn't do lengths here, I did congruency. Well, if the sides are the same length, then the sides are congruent. So once again, that concept, that link between measuring things and them being equal and the object themselves being congruent, I just switched back and forth between them. I like to write the definition like this because it makes more sense to our brains, like the idea that something would be the same length and the same measure. But then when we actually start writing statements, I like to use congruency statements because our ultimate goal is to say the two triangles are the same. Now, why would you want to do this? Well, let's say you're building a bridge, okay? And let's say your bridge kind of looks like this. You may have seen bridges like this before. Okay, there's like treacherous water down here. Okay, but your bridge has triangles to support it, and all the triangles need to be the same. They need to be congruent. How are you going to verify that they're all the same as you're building it? How does the workers know that they got this right and move on to the next triangle? Well, we're going to be discussing that. One way they could do it is if they knew all the parts are congruent. They measured each angle painstakingly, but there's actually way better ways to do it. Okay, so we know that two triangles are congruent if all pairs of corresponding sides are congruent and all pairs of corresponding angles are congruent. We may wonder if knowing less information about the triangles would still guarantee that they're congruent. For example, we may wonder if knowing that two angles and the included side, included means between, of one triangle are congruent to the corresponding two angles and the included side of another triangle, a set of criteria we would refer to ASA. Get it? Angle, side angle, two angles, and the side in between the two angles that connects the two angles. If we knew information about those, is that enough to know that the two triangles are congruent? And if we think that is enough information, how might we justify that this is true? Here is a diagram illustrating ASA criteria for triangles. Okay, so we know that based on the diagram which angles are congruent, which sides are congruent. By the marks, we know that angle A is congruent to angle R. We know that angle B is congruent to angle S. And what about the sides? Well, side AB and side RS. Now, it doesn't really matter because this side is just a line and this side's just a line. So it doesn't matter if we go BA and then RS. But let's work on being aware of orientation because sometimes it does matter. It doesn't matter in this case, but sometimes it will matter. So let's pay attention to it. If I say BA, that goes from double arc to single arc. I should say SR, which goes from double arc to single arc. So I'm going to say segment BA is congruent to segment SR. To convince ourselves that the two triangles are congruent, what else would we need to know? We would need to know that CA is congruent to, again with orientation, TR. And we would need to know that CB, segment CB, is congruent to segment TS. And there's one more angle we don't know about yet. That's angle A, or angle C is congruent to angle T. Use tracing paper to find a sequence of transformations that will show whether or not these two triangles are congruent. List your sequence of transformations. Okay, I'm going to pause this video there and go ahead and see if these two things are congruent. How would you need to do it? Maybe look back at the last lesson for our algorithm. And we will get to these in part 2.